So hi, today the main topic is the B3 extended version of it. This extra research paper I read before making B3, and I think it is also good paper that explains the B3. But for the I think the best explanation um, is the one who says the one title is ubiquitous DB3. The research paper um I just explained from the previous video. I think that research paper is most greatest papers that explains the B3. But this thing is kind of like extends of the B3. So basically, what in this research paper says that the B3 is used for the in-memory indexing database. So basically, B3 supports the what we know the insertion and deletion and search operations. But the problem is that when the node size is more 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 bigger, it's gonna be hold on. So trade-off between point and range operation. So because the 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 problem of the B tree is really kind of efficient for the point operation. Example, if you wanna just search one the key is 3, it's gonna be really easy because you're basically searching the record key, which is 3, and the time complexity is O log n, and the and this part is gonna be db like this. The b so m is the minimum degree of it. So more you increase the minimum degree equals to the more will have the better better time faster time complexity is because basically the m is equals to the how many the record keys that can the page have, because bit inside the bit tree the page can have multiple record keys. So there's gonna be a bunch of it. More you have, more record keys is faster, but the size is bigger, so that's gonna be it's kind of retreat of it. Of course, if it's like um if it's if the size is bigger, it'll be more faster because it has more bigger minimum degree and it has less the height less height than the smaller minimum degree. So and this general present BP3, which is the variant of it, they use buffer partition array rather than just putting the key values of the um, B3. So this that was kind of really the problem I also faced, because when I implement the B3 and I have to sort as a like example, if I wanna store 134, but if it's like 143, I have to sort it. So I just store record key as an array. But the problem is that I have to put this time complexity with sorting um with plus this point operation of it. And last and I think there's another way to solve this issue. There's could be using dictionary or just a bunch of key value object would be more nice. It's just like um Redis using this kind of key value um, page layout. So this basically um, journal explains about how how they approach this kind of problem. They know there's like B+3, but they use buffer partition array to solve this kind of problem. They make some kind of efficient node layout to increase the time complexity of the normal bit tree. So this part is basically explaining us of B3. B3 is kind of and this introduction is really explained well, and the all log bn this kb and this this is kind of really sorry about keeps on talking about those kind of words. um this log n, those math formula, it just somehow awake me because I thought the worst case for the range operation was o log b n. I thought wait sorry b n plus k. Before reading this journal, I thought the time complexity was log bn plus k, and k is the how much range, the number of the range I have to search, and the log bn is equals to the normal time complexity of search or insert whatever stuff. So that was how I think of it, but I found out that the formula is actually the k divided by 8, and I was figuring out why is it like that, and where is the k is size of the range. So if the size of the k is range, why do we have to divide the b? The reason why we have to divide into b is because the even though you do range stuff, the minimum degree example, if it's like non-binary tree, it makes sense. Like this part makes sense, but the reason why we have to divide into b because even though it is range operation, we have to put that this range operation is even though if it's range, it has to go through the page layout of the B tree, and this page or the node in the B tree can have multiple keys. More you have b minimum degree, let's say minimum degree equals to b. More you have b, you have more faster or on the range operation or just the point operation. So that's why we have divide as a b. So that's kind of really making me read more about this stuff. So also this research paper talks about point and range operation in the key value stores. My general question is, why do you have to think about key value stores? Why I mean like why don't we just can use the hash map of it? Key value storage is gonna be nice, but we have to I don't know. But the first of all, I had really zero zero knowledge about the difference between key value storage and the hash map. If the hash map is more better, why don't we use hash map for the points and range operation for it? So that was my theory of it. My so my plan is I already implement the balance and the insert and search operation. Based on this, I will implement this more BP3 or the extended version of the BP3, and I will integrate with the node page layout because in the research paper it's saying about it doesn't really store as an array, it stores as this byte here. And I will put this on like this so I don't have to think about some kind of memory leak of it. So I think this is it. Have a nice day. See you next time. Bye bye.